All right, so today we'll take a look at the solubility product of silver acetate. So let's start off thinking about what all of these words mean. So silver, as you guys probably know, is generally Ag plus. So silver plus, and then the counter ion acetate here. Here's the Lewis structure for it. So there's what the Lewis structure looks like, and then this is commonly abbreviated as negative OAC. So that's the way I'm going to write it. So silver acetate combined is AgOAC, right? Cool. So let's take a look now at what the solubility product means. And then if you think back to class, right, the solubility product means multiplication. Solubility is how much stuff is dissolved. So what you're taking a look at is your silver acetate as a solid being dissolved into silver plus and acetate minus. So the solubility product constant is going to be these two multiplied by each other, right? This gets KSP. And so this is going to equal to the concentration of the silver plus times the concentration of the acetate. So you can see in order to figure out the solubility product, the question that we're asking is how much silver is in my solution. So anytime you ask how much blank is in my blank, right, in this case, how much silver is in my solution, what you're kind of asking is a titration question. Titration. So we're going to use titration to figure out how much silver is dissolved, and from how much silver is dissolved, we can figure out the solubility product constant, right? One thing you kind of want to keep in mind is the amount of silver dissolved. If there's no other acetate present, these two will be equal. If there is some present, then you got to do a little bit more thinking ahead. Think ice tables, rice tables type of thing. So let's check out the experiment here. So we're going to do a titration. So let me draw a little titration setup. Cool. So up here in our burette, we're going to have our silver acetate. In the first step, it'll just be silver acetate by itself, and then we're going to add some ions, some common, some not common, and see what effect that has on the solubility and the solubility product constant of the silver acetate. And then down here, you're going to have this yellow solution. We'll see what the yellow comes from. But in here is 10 ml of 0.0500 molar potassium chloride. Right, so that's volumetric, so we want to know exactly how much of that there is, and it's 10 mils of this 0.05. And then you have approximately 1 ml of this potassium chromate, just approximately 1 ml, because this is our indicator, so we don't really care how much is in there. It's just going to be what tells us to stop the reaction, and this is where the yellow color comes from. So the yellow color comes from the chromate in here. So we're going to start titrating, and the first thing you're going to notice is one thing's going to happen. You may not notice this one. It's a little difficult to see if you're not paying too much attention to it. All right, so we're titrating in here. This is yellow, and then what you'll see, it'll kind of become more opaque. I don't really know how to draw this, but basically some silver solid or some white solid is going to show up. Some white solid is going to show up at first. And this is going to be due to the reaction with silver plus and chloride minus. These two combined are very insoluble, silver chloride. And so you get out a solid of silver chloride. And this is a white solid. With the silver coming from our titrant, and then the chloride coming from this solution, right? So the silver is going to react with the chloride, and as long as that is happening, all you're going to form is a white solid. So you'll be able to see a little bit in the video, but not too well. Here's a little picture of what this looks like. What you'll see is the solution kind of gets more opaque and more murky, but still yellow. That's just the silver chloride precipitating out. All right, so after that, another thing's going to happen. So 2, and this happens once all the chloride is used up. So once all the chloride is used up, something else is going to happen. You're titrating right here, and this is going to be your indicator. Your indicator is going to tell you to stop right here, and you want to stop as soon as this goes to a reddish brown, right? So stop as soon as a light yellow brown, or we'll say red brown color appears. So as soon as this appears, you want to go ahead and stop your titration. Your indicators indicating you are done. And what's going on is now you've used up all the chloride, right? All the chloride is used up. So now you're having another reaction. This is going to be between the silver and the chromate. So under step 2, what's going to happen is some silver is going to react with the chromate to form silver chromate as a solid. And this is a red-brown solid. So this only happens once all the chloride is used up. So once the chloride is used up, then we're going to precipitate out some red-brown silver chromate, and that's going to be your endpoint indicator. So that's going to look not quite like this. This solution is showing a very concentrated amount of silver chromate, but basically what you're looking for is a slight brown color. You'll see in the video it's going to be a much lighter color because we want to stop as soon as any amount of this silver chromate is forming. And then there's your endpoint. From the amount of silver you used, you know how much potassium you used. You can figure out how much silver was in your solution, and thus eventually the solubility product of this silver acetate. All right, so the first step in our titration is to condition our burette. So as you can see here, I've got my solution of silver acetate, and I'm going to use it to condition this burette. So currently my burette is empty, so I'm just going to fill it up just a little bit to condition it. So go ahead about eye level. I want to put our funnel up here, and then hold it just a little bit so that way the air has somewhere to escape. Make sure your burette is closed, and then go ahead, just pour in a small quantity of whatever is going to end up in here, in this case, the silver acetate. Should be good. You can see I've got a bit of a waste container down in the bottom, and then I'm just going to let some of the silver acetate run through. That way everything in here is silver acetate and not water or dry gunk or anything like that. So cool, that should be fine. So the tip of my burette is now conditioned. Now I have to kind of condition the rest of this volume up here. So let's take a look at how I'm going to do that. So I'm going to take the burette, take it off of here, and I'm simply going to pour the silver acetate back into my waste container. And while I'm doing that, I'm going to give it a swirl. That way the silver acetate touches all of the burette. So pour it in here and just give it a nice swirl through. There we go. Now we've conditioned our burette, and every liquid in here is our solution of silver acetate. All right, next up, we've got to fill our burette with our solution. So I have my burette right here. I'll put the funnel up here and then just lift it up a little bit so there's a little gap here so the air can escape and stuff doesn't flow over. And I'm just going to go ahead and slowly add about 50 ml of our silver acetate. We don't want to go above the 0 line of the burette. Should be good. And now what I'm going to do is just let a little bit out in the bottom just to make sure our apparatus is good to go. So just pour some out of the bottom. Looks like it's working well. And then I'm going to read the burette for my initial reading. All right, next up I have to make my solution to be titrated. So here I've got my potassium chloride, and then I'm going to go ahead and transfer exactly 10 mLs into this Erlenmeyer flask, right? So we want this to be volumetric. So we're going to go ahead and use our volumetric pipette. So you can see this one dispenses 10 ml, and that's where your bottom of your meniscus wants to be, right? Right at the bottom of this line right there. And to do that, we're going to use this pipette bulb. So we're going to stick this on here and then just turn this knob to suck some stuff up. And then when we want to dispense it, just go ahead and press that button right there. So let's check it out. Insert my pipette bulb nice and tight. And now I'm going to fill with 10 mLs of the potassium chloride. Put my pipette in the solution and then start turning this knob and get to the 10 ml mark. So let's check this out. Once it stops bouncing, as you can see, the bottom of my meniscus is right about that 10 ml line. So go ahead and dispense this into my Erlenmeyer. And then according to the lab manual, next thing we want to do is add 15 mils of water. So I've got 15 mils of water in this graduated cylinder. And then the next step is to add 1 mil of our indicator. In this case, it's this potassium chromate solution. So you can see it's a nice yellow. This doesn't have to be exact, so we're going to only add about 1 mil. So I don't know if you can see this pipette bulb, but this reading right here says 1 ml, so we'll just fill it up to there and pipette approximately 1 ml. And as you can see, our solution is this nice, bright yellow. And now we are ready to get started on our titration. All right, so now we're ready to titrate. We have our burette filled with our silver acetate and then our solution to be titrated here. So what we're going to do is we're going to slowly open up this stopcock here, and then we're going to pour in some titrant here, and then we're going to swirl. You see I have a little bit of headspace between the end of the burette and the beginning of the Erlenmeyer. That's kind of personal preference. I see a lot of students kind of go like this. The issue there is if you're not swirling carefully, you're going to make contact with the burette and you might actually break it off. So I like to leave a little headspace. That way, if I over stir, I just mess up my experiment instead of breaking the equipment. So I'm going to go ahead and start titrating away. So I'm going to open up the stopcock a little bit and put up the stopcock a little bit and try to get this to come out nice and slowly. So you can see, start to add dropwise. You can see the little red down there disappearing away. So once that red stays, that's going to be our endpoint. You can see it's still going away quite rapidly. can see, my camera fitting is not the world's most secure right now. As you can see at this point, my solution has turned into this kind of reddish brown instead. You can see the white silver chloride in the bottom, and then there's a reddish brown to it. So we're either right at the endpoint. All right, so you guys just saw part 1 going on. We won't do a repeat of that just because there's no point to kind of watch the video again. And part B, C, and D, again, it's the same experiment, just modulating a couple things. I'll just give you the numbers. That way you don't watch endless series of titrations, right? So for part B, it's pretty much the same thing, right? Still your 10 mLs of your KCl, but this time you're titrating with silver acetate that has a mixture of 0.1 molar potassium nitrate in there. So there's 2 things in that mixture. Think if there's any common ions. And we'll say that this took 8.60 ml to complete this. In part C, you got to be a little bit careful. You're titrating actually 25 mils of this KCl. And this time you're doing it with this silver acetate and silver nitrate combo. So silver, right? We'll say that this took 9.80 mLs to complete to the endpoint. And then in part D, be careful, you're back to the 10 mLs here, and this time you're using silver acetate and 0.1 molar sodium acetate, right? So common anion there. And we're going to say that this took 18.40 mLs to completely titrate. So I just want to remind you what kind of reaction you're talking about here. You're talking about silver acetate dissociating or precipitating out, right, between Ag plus and acetate, right? So you see an equation there, you see an equilibrium, so you kind of want to think about your Rice tables, right? You ignore this guy right here because it's a solid, and then you want to solve through, right? For all of these experiments, what we're solving for is the concentration of the silver plus, and so we're seeing what's this value at equilibrium. So there's a little hint there, and think about what you have to plug in. Sometimes you'll plug in zeros here, sometimes not.